So in this question, we're told a circle C has a radius r, and it lies in only the first quadrant, and it touches the x-axis and touches the y-axis. We're told that we also have a line L, and it has the equation 2x plus y is equal to 12. And in this question, we're asked to show that the x-coordinates of the points of intersection of our line L with our circle C satisfy the following equation. That is 5x squared plus 2r minus 48 lots of x plus r squared minus 24r plus 144, and that is equal to 0. So firstly, we'll just take a look and have a think about what these two bullet points mean. So here we have a kind of diagram here. So this is our x-axis and our y-axis. So we know the first quadrant is this. So we know that the circle only lies here, and we know that it's going to touch the x-axis here and the y-axis here. So we know our circle will look something, not exactly, but it'll look something like this. So we now need to have a think, what will this take equation of the form? So we know that the standard equation of a circle will be, so we'll just put a C in here, but we know that the standard equation of a circle will be here, this sort of thing, where the center is 0. So we know that for our circle, the center will have been shifted up from here to here. So this means to find the center, it's going to be shifted by the radius along the x-axis and by the radius on the y-axis. So therefore, we'll just write this down. So the center of the circle is shifted by r units along the x-axis and the y-axis. So therefore, we can say that the equation of C will be as follows. From the general form of the equation of a circle, we'll have x minus r. We'll square that, then we'll add on y minus r, and we'll square that too. And we know that that is going to be equal to the radius squared. And then we know our equation L, so it has the equation, I'll just write in here, 2x, and then we're going to add y, and that's equal to 12. So we're given that in the equation. So we're given that in the question here. So we rearrange that, and we can say that y is going to be equal to 12 minus 2x. So this means we can now be ready to move forward with the question. So what we want to do is we want to take this equation here and substitute it into this equation here. But to do that, we'll need to simplify this equation for the circle slightly first. So we'll just continue working down here, and we're going to expand our brackets. So x minus r squared, that is going to give us x squared, and then we're going to subtract 2 lots of r multiplied by x, and then we're going to add on r squared. Likewise for the y minus r squared, we'll add on y squared, and we'll subtract 2 lots of r multiplied by y, and then we'll add on r squared also, and that is equal to r squared. So we can just tidy this up slightly, so we can see that we have an r squared here, an r squared there, and an r squared there. So we can simplify this and add these two r squared together, and then subtract r squared, and this will give us that the other equation is equal to 0. So we'll therefore have x squared plus y squared. So I'll just rearrange it slightly so both our squared terms are at the front, and we'll subtract 2 lots of rx and 2 lots of ry, and like I said, we have 2r squared minus r squared, which leaves us with r squared, and the other side is now equal to 0. So what we can do now is we can substitute this in, so I'll just write that in here. We'll substitute this in, so then we're just going to do this as follows. So our x squared stays the same. Our y squared, we're now going to have plus 12 minus 2x, and we square that, and we're going to subtract 2 lots of rx. Then we see another y term here, so we know, we'll just scratch down there where our 2 y terms are. So then this time we're going to subtract 2 lots of r, but we're going to multiply it by 12 minus 2x, and then we add on r squared, and that's all equal to 0. So as you can see, we've basically eliminated all of the y's in this equation, and we now have all in terms of the x and r's. So our next stage here is going to be to expand this bracket here, and also we'll deal with this bracket here as well. So we'll have now, x squared will stay the same, and then we have 12 times 12, which is 144, and then we'll have 12 multiplied by negative 2x, and we'll have two lots of that. So that's two lots of negative 24x, which is negative 48x. And then we'll have a positive 4x squared. And then continuing on, we'll have take away two lots of rx. Then we're going to minus 2r multiplied by 12, which is 24 lots of r. And then we'll have negative 2r multiplied by negative 2x. So that is going to give us a positive, since we're multiplying two negatives, and it's going to be 4rx. And then we'll still have this r squared on the end. So now we can simplify this by collating all the like terms. So firstly, we have an x squared and a 4x squared, so that's going to give us 5x squared. Then taking a look at all our terms which have an x, we're going to have negative 48x. We'll keep that on its own for just now. And then we have negative 2 lots of r of x and 4rx. So combining them together, we have 4 minus 2, so we have remaining positive 2rx. And then from here, the rest of it remains the same, in that we have positive r squared, and then another term in terms of r, we have negative 24r, and then finally, constant on the end, we'll have 144. And this all still remains equal to 0. So all I've done here is collate the like terms and made this into a slightly simpler form. So now we can look back to the question. We're getting quite close to what we wanted. So we have our 5x squared. So we'll just give that a little tick here. And if we put brackets in here, we have our r squared minus 24r plus 144. So we'll tick that. So we just need to now look and see what we can do to go from negative 48x plus 2rx to 2r minus 48 lots of x. So we see we can take out the common factor of x here. So therefore, this is going to give us the required answer that we're asked for. So we have our 5x squared that remains the same. So then now what do? Well, we want to take x out as a common factor. So that is going to leave us with 2r minus 48. We multiply it by x, and then we have our term r squared minus 24r plus 144. And to be like it's in the question, we'll pop our brackets in there, and that's all equal to 0. And that is the answer that the question asks for. So we'll write in as required. Therefore, we have completed this question, and I'll now go over where we picked up our marks. So we pick up our first of 3 marks for deducing the correct equation of the circle. So that was when we knew to shift the circle by r units along the x and y axis, which gave us the center of the circle. So we pick up our first mark here when we got the correct equation of the circle. We then get our second mark for attempting to form an equation with the terms x squared, x, and r squared. So where is this? This is at the point here where we start to substitute in our y equals 12 minus 2x equation. So we'll give ourselves this second mark just about here. And then we receive our third and final mark for concluding with the correct answer, and that was the answer that the question asked for, which we've shown here. So in the next part of the question, we're given some further information, and we're told that L is a tangent line to C. So basically, what does this mean? So if we have a circle like this, then if L is a tangent, then this means that L will touch C at this point here, for example. So we're asked to find the 2 possible values for R, and we're to give our answers as fully simplified surds. So we know that if we have a tangent line, then we have one repeated root, which means that the discriminant will be equal to 0. So this is our equation for the discriminant here. That is b squared minus 4ac, and we know it's going to be equal to 0 since we have one repeated root. So I'll just note in here that this is the discriminant. And we recall from part A the following. We have that 5x squared plus 2r minus 48 lots of x plus r squared minus 24r plus 144 is equal to 0. So we see this is a quadratic equation, and we have coefficients in front of the x squared, the x term, and then free of the coefficient x2. So this means that we can say that we have that a is equal to 5, we have that b is equal to 2r minus 48, And finally we have that c is equal to r squared minus 24r plus 144. So we can substitute these in to our equation for the discriminant. So therefore, we have b squared minus 4ac is equal to 0. And just carrying this along here, we have that b squared is 2r minus 48 squared. And then we're going to take away 4 lots of a, which is 5. And we're going to multiply this by c, which is r squared minus 24r, and we add on 144. And we know that this is all still going to be equal to 0, and we now effectively want to solve for r. So we do this first by doing a bit of simplification. So we expand this first bracket, and what does this give us? So this gives us 4r squared, and then we'll have negative 192r. So this comes from 2r multiplied by 48, and then we have 2 lots of that, and then we're going to have 48 squared, which is 2304. And then for this rest of the equation, we have that negative 4 times 5 is going to be 20. So we're then going to have negative 20 multiplied by this bracket, so that's going to be negative 20r squared. Then we have negative 20 multiplied by negative 24, which is positive 480. Lots of r, that is. And then we have negative 20 times 144, which is negative 2,880. And that still is all equal to 0. So we're now going to simplify things a little bit further by collecting our like terms. So we have 4r squared minus 20r squared, which is negative 16r squared. And then for the r terms, we have 192. So we can see we have that here, and 480. So we have 480 minus 192, which leaves us with positive 288r. And then for the constant terms, this leaves us with 576 here. And that's all still equal to 0. So to make this easy to solve, we can divide everything by 16 or negative 16. So we divide by negative 16. So therefore, that's going to leave us with r squared. And then 288 divided by negative 16 comes out as negative 18. We have r. And then finally, we have the constant is going to be 576 divided by negative 16, which is 36. And this is equal to 0. So now we'll use the quadratic formula. So we'll just write in quadratic formula, and we'll have that this time a is equal to 1, b is equal to negative 18, and c is equal to 36. So therefore, we'll have our value of r is going to be equal to negative b plus or minus b squared minus 4ac. We square root that, and then we divide it by 2 lots of a. So then subbing our values in, we have negative 18, which is 18. Then we're going to add on negative 18 squared. Then we subtract 4 lots of, well, what's a? So a is 1. So we'll just put that in. And then c is 36. And then we put our square root in here, and we divide everything by 2 lots of a, which is 2. So in simplifying this here, this comes out as 18 plus or minus 6 multiplied by the square root of 5, and 2 is the denominator still. So just to note, how do we go from here to here? So we kept our 18 and our 2, and we put the things inside the square root into the calculator. So in simplifying this, we can divide everything by 2. So therefore, we can conclude that r is equal to 9 plus or minus. So we have the 6 root 5 divided by 2 is equal to 3 lots of root 5. And that there is our answer. And we finished this question and concluded that the 2 possible values for r are going to be 9 plus 3 root 5 and 9 minus 3 root 5. So now to just take a look and see where we got our marks for this question. We received our first mark for attempting to use the discriminant to begin to find the roots. So we will give ourselves this mark when we substituted in our values just about here, and when we kind of started with the finding the roots process. We then achieve our second mark for getting a correct quadratic equation in r. So we did that when we got to this point here. And it doesn't actually matter. You would still get the marks if you left it at this stage here, but I thought it would be good to simplify it to make the next stage slightly simpler. We then pick up our third mark for having a correct attempt to solve our equation for r. So this was when we start to use the quadratic formula and substitute the values in. So we'll give ourselves this mark here, and then we received our fourth and final mark for concluding with the correct answer, and that we showed that we worked accurately and we gave our answer correctly and left it in surd form like the question asked for.